Hi, everybody. Hope to spend a little bit of time on chapter 11 here of the textbook. And this is section 5, where we go through three example hypothetical regressions that are actually regressions that have been run before. But here we don't give you any of the details. We just rather speak about some of the validity issues, and these validity issues all add up to credibility. And as you'll remember, the validity issues are omitted variable bias, sample selection bias, measurement error, and reverse causality. Those are our main validity issues that we want to address whenever we're looking at any particular regression. So in this section 5, we make up three examples, and again, an important thing is for each example, to think of what is the entity of observation. We'll try and be clear about that as we go through the entity. What is each row in these data sets? And validity issues will depend partly on what the entities of observations are. Especially sample selection bias will depend on what the entities are. If we're observing all the counties of the United States, all 3,000 of them, and that's our entity of observation, then there isn't any sample selection bias because we observe all the counties that are in the universe and the population of counties. If, however, we're observing, say, individuals or non-uniform entities like uh, places, where it's not clear what a place is, where we're defining that perhaps somewhat arbitrarily, then we might indeed have sample selection bias issues. So let's go and take a look at each one of these three. The first one is policing and crime. Um, the second one is car driving and CO2 emissions. And the third one is the gender of children and labor force participation. So let's talk a little bit about the first one, policing and crime. We can imagine the X variable is a measure of policing efficacy. So how good is policing? How effective is policing? How many resources are devoted to policing? And the Y variable is the crime rate. And of course, our main problem here, now I'm thinking about it, did I mention it in my validity issues? Reverse causality is the main problem here, or simultaneous causality, reverse causality, because, of course, high crime rates probably influence the size of the police force, and the size of the police force um, influences the crime rate. So policing efficacy or the size of the police force is going to cause presumably reductions in the crime rate, but the crime rate itself causes the size of the police force or how many resources are devoted to the police force. So we have simultaneous causality or reverse causality. One variable is causing the other, and the other variable is causing the first. The causality goes both ways in this case. So that's a pretty obvious case of a validity issue that we would want to take into account. But we'll also have measurement error issues. How do we measure policing efficacy? If a jurisdiction hires a whole bunch of people who aren't qualified to be police officers, or who are barely trained to be sworn police officers, is that an improvement in efficacy? We might even think that it would be a decline in efficacy. So hiring a whole bunch of people who have no real qualifications to be police officers and who aren't trained to be police officers, we might think actually lead to an increase in crime rather than a decrease in crime, because the police officers themselves, because they're not trained, or because they themselves are more likely to be prone to criminality through the selection process of the police officers, right, makes the situation worse off. So we'll have all kinds of measurement errors in this relationship. Similarly, the crime rate, because because crimes are typically self-reported. You can't have a crime if nobody reports the crime. Crime rates themselves are measured with considerable error, and that error can vary with other variables. So we can imagine heavier police presence of untrained police officers actually leads to a lower reporting of crime because nobody wants to call these bad police officers who are just as likely to come and uh, rip you off as the vulnerable citizen calling them. So we have all kinds of measurement issues, reverse causality issues, and of course, there's many omitted variable issues. There's many variables that one can think of that are correlated with the hiring of police, and also correlated or causal of the crime rates. And we would have those as omitted variables. So we have all kinds of validity issues with a regression like this, and that's why criminology or the econometrics of crime is a very difficult area in econometrics because all the validity issues are present for that. Let's turn to the next one, and that is car driving and CO2 emissions. So here again, we might think this is a very typical social relationship that we're interested in. Cars, as they're driven, generate CO2 emissions. CO2 emissions lead to global warming, and we would want to understand that relationship. But of course, there's many validity issues with this because right away we understand there's simultaneity or reverse causality here. People's decisions about how much to drive themselves might be influenced by the levels of CO2 emissions. So if you have a car that emits a lot of CO2, you might be more reluctant to drive it. Your neighbors might look at you and say, why are you driving that old car that doesn't have a catalytic converter and is emitting pollutants into the environment? You feel bad, you drive it less. So there's a reverse causality that's very clear. It depends on what the unit of observation is. But even at a different unit, say at the county level, where we typically measure aggregate CO2 emissions, we could imagine that as CO2 emissions increase in the county or the cities that form part of that county jurisdiction impose congestion restrictions on driving. So it's the CO2 emissions that are affecting the driving pattern, not the other way around. So we're going to always have reverse causality in a regression like this. So it's nice to see, this is an example of where many of those validity issues are there. We have a lot of problems with what the entity of observation is here. Is the entity cars? Is the entity households? Is the entity the county? What exactly is the entity that we're observing in its relationship between amount driven and CO2 emissions? Those, measurement issues change because of computerized sensors. So whereas before there was no way to measure CO2 emissions at the individual car level or the household level, now because of sensors embedded in cars, we could have a pretty good idea of how much CO2 any individual household is emitting. But we might have sample selection issues. That is, we might not observe, because they don't have sensors, households that are driving older cars. So those aren't observed, and it's partly determined by the y-axis, how much CO2 emissions. Households that don't have measurable CO2 emissions because they don't have sensors are excluded from the analysis. So we have a sample selection problem. So that's an interesting area. And let's go to the last one. Our last relationship is gender of children and labor force participation. So here we might imagine that we're demographers, sociologists, feminist economists, and we imagine families having children and the gender composition of the children, which is largely random, but not completely random, because many parts of the world you could have preterm abortion after ultrasound if you have particular strong preferences for the gender of your children. There are many gender stereotypes that suggest that if you have boys, then the mother should stay home and not be working. Alternatively, if you have girls, the mother should stay home and not be working. So there's going to be gendered effects, we might imagine. That might be our hypothesis. We're going to try and determine whether that's true or not, whether the gender composition for whatever society is that we're examining, whether the gender composition of children affects the labor force participation of the parents, the mother or the father, and other non-traditional families, of course. So we have all kinds of interesting issues that come up in a relationship like this, but primarily, one that's of issue is the sample selection issue, because many families will be choosing not to have children, and of course, their decision about how many children to have and to not have children is related to their labor force participation decision. Parents, we might imagine, that have a high preference to participate in the labor force to be fulfilled through their work may be choosing not to have any children. So we won't observe the gender of their children. And so they're being selected on the basis of the dependent variable. So an interesting problem arises there. Uh, I think I'll stop there. This has just been a quick overview of this section in chapter 11 that concretely looks at three regressions, imagined regressions that we might have. You have, remember, four other regressions that you should be thinking about. The Nathan Nunn regression of the slave trade's enduring effects on GDP in African societies, the knowledge frontier of teachers and student success, the sexual misconduct of faculty and student continuation in those majors. And there's one other one which I'm blanking on right now. So those are the regressions where we actually have some results and should be thinking about the validity issues associated with those regressions.